Hi everyone, welcome back. Do appreciate you keep on watching these videos. Your support really is appreciated. Thank you. Today I want to talk to you about a specific instance of software, namely data. Now, when we apply any kind of deviation-based safety analysis to data, what we're aiming to do is to determine how any unanticipated changes or impact or effects on data could manifest. And by doing so, we aim to mitigate these unanticipated changes through perhaps the derivation of safety requirements that will be later manifest in a design. But often it's not sufficient to just think of data in a generic term as an entity on its own. And the reason for that is, if we're going to determine all potential ways by which data could be somehow adversely impacted, changed, etc., we need to be able to identify all the mechanisms which, if they manifest, could realise the data change. So to do so, we need to think of data in its three different states. So what are those states of data? The first state is data at rest. The second is data in motion. And then we have data in transition. And if we think about each of these in turn, we'll start to think about and identify potential causal mechanisms which, if they manifest, could impact that data. Now, any of these causal mechanisms could manifest in any one of these states or in all of these states, but we need to think about them in turn. So thinking about them in turn, we first have data at rest. Now, data at rest is data that's currently in memory or storage. So we could start to think about how perhaps that data could be inadvertently overwritten, how it could be written to by mistake perhaps. For data in motion, this is where the data is moving along a communication path or a network. And here we could start to think about how that data could be delayed, how it could be corrupted, how the message payload could be changed. Now that could be through things like a bit flip, or it could be through a malicious actor. Either way, we need to identify all potential ways that data could be corrupted, delayed, and any other. And finally, we have data in transition. And data in transition is the data that is having some kind of computation applied to it. And here, perhaps, maybe the algorithm that does the computation was not designed correctly. So the value that's resultant is not fit for the intended purpose. So when we're thinking about applying safety analysis to data, don't just think about data in a bland, generic way. Think about the different states of data. We've got data at rest, data in motion, and data in transition. Apply the deviation-based analysis to each of these different states of data, and we will have a more complete, correct, and robust analysis, and we will identify effective mitigations to manage any potential hazardous condition which could be realised. Hope you find that useful. Thank you for watching, and I'll see you next time. You know why. All the cool kids want to be a safety scientist. See you next time, guys. Cheers. Take care.